Hi, in this video I want us to look at possibly the most useful of all the zone fossils, a group we call the ammonoids. The example you can see here is a particularly enormous one, but even where we find these as tiny little fossils, and you can find these right the way around the Glamorgan coast, they are incredibly useful for dating the rocks that we find them in. We need to look at why that is. Now, the ammonoids are part of a bigger group that we call the cephalopods. Now, cephalopods include these organisms you can see here. Octopus, squid, cuttlefish, all live today. But they're different from the ammonoids that we look at because those modern examples don't have shells. The ones that do have shells only have one living survivor. That's called Nautilus. We need to look at that Nautilus a little bit more in detail, apply some uniformitarianism to understand a bit more about these very useful organisms. The example you see in the middle there, that's Titanites. That's the biggest of these cephalopods, the biggest of the ammonoids that's been found. Okay. This is Nautilus. Nautilus is an unusual animal, to say the least. It was actually one of the first ammonoids to evolve, and it's one that's lasted pretty much unchanged for hundreds of millions of years. Because we still have Nautilus, we can still see how these animals must have lived. They were exclusively marine. They only lived in the sea. And they swim around in the sea by jet power. They suck in water and squirt it out to move themselves around in the sea. There's a link to a video that shows you a living Nautilus included with the lesson notes. What's interesting for us though as geologists is the shell. On the left hand side here you can see a cross section cut through a shell of a Nautilus. You can see that the shell is coiled on itself. This is because as the animal itself grows, it needs a bigger shell, so it secretes a bit more shell material, a bit more calcite onto the end of its shell and will grow it and get bigger over time. It coils around itself to make it hydrodynamic. Now the interesting feature is as the animal continues to grow, the animal lives in the body chamber. But behind it, it creates a wall of calcite. This wall is called a septum. Now that wall of calcite is formed after the main body of the shell. It creates a whole series of chambers within the shell that the animal can use to strengthen its shell and also to give it the buoyancy that it needs. But for us as geologists, what's really crucial is where that septum, where that inner wall actually is joined to the inside of the shell. Because where that happens, it makes a very distinctive pattern that we can see in the fossil record. These are the three groups of ammonoids that we can use to date rocks. We have goniotites, ceratites, and ammonites. And those three groups evolved over time. You can see on the geological column on the right that we have these three groups. Goniotites existing in the Devonian, Carboniferous and Permian becoming extinct at the end of the Permian. The ceratites lived during the Triassic, when they became extinct, and the ammonites then lived in the Jurassic and Cretaceous, before they too became extinct. We can tell these shells apart, not because of the shape of the shell, which you can see has this distinctive coiled shape in all of them, but because of the shape of the join between the septum, this inside wall, and the inside of the shell. If you look at this feature is called a suture line, and the suture line changed over geological time. If you look at a goniatite, it has quite a simple pattern of saddles, the high bits, and lobes, the low bits. It's almost quite a curvy line. A ceratite sees a change in that pattern. Here we can see that the saddles in the line are still quite smooth, but the lobes, the low bits, are starting to get a bit frilly. Now, as they get a bit frillier, a bit more complex, that means that there's more wall on the inside of the shell. So it gives a stronger shell. There's an evolutionary advantage to it. By the time the ammonites evolved, we see a very complex pattern. It's frilly all the way along the line, the saddles and the lobes. So it's a really distinctive feature that allows us to identify which type of ammonoid that we can find, and therefore what age the rocks are. Okay, so that's the work really on page 10 and the top part of page 11. Let's try and put that, or try and apply that idea. On a separate sheet, I've given you photographs of different ammonoids. I've also given you the specific age in which those ammonoids lived, because these ammonoids evolved quickly and became extinct very quickly. Using the information on that additional sheet about the ammonoids and also about the detailed extract from the geological column I've given you, can you put those ammonites in order? So I'd like you to press pause now and have a go at question 7 on page 11 of your Theme 9 booklet. You will need to use that additional sheet that's been attached with this email. Have a go at that now. Okay, let's see what we've come up with. This is the table we're trying to fill in. The oldest of these is G, which is a goniatite. E, which is also a goniatite. C, also goniatite. You can see if you look at the photographs carefully, this simple suture pattern, these curved lines that we can see preserved on the fossils. F, which is next, is a ceratite. We're seeing a more complicated pattern in the suture line. I, which is the next one then, is an ammonite. We're now into the Jurassic. So the rest of these ammonoids, A, D, H, and B, must all be ammonites. Okay, to conclude, this rapid evolution of really identifiable features, this change in the suture line, allows us to use ammonoids as uh, superb zone fossils for a big chunk of geological time, going from the Devonian right the way through to the end of the Cretaceous. They're incredibly useful things, and we can define really quite short periods of geological time using them. They often come up on GCSE exams as a way of helping us to date rocks, and that can be in the practical exam or in the theory exam. Next time, we need to look at a group of fossils we use to zone older periods of time. I'll see you then.